Hello, welcome to Anybody Can Learn. Today we will learn learning rate in more detail. Learning rate is almost used in every optimization algorithm. It determines how much the model's parameter change. Model's parameter means weight. So learning rate determines how much the weight change during each iteration. The changes happens during each iteration of the gradient descent, and that change is determined by the learning rate. Learning rate controls the size of each step taken during each iteration. The goal is to move towards the minimum value during the gradient descent. So learning rate is used to update the weight, and the formula for update is W new is equal to W old minus eta times gradient, where W new is a new weight, W old is the old weight, eta this is a symbol used for the learning rate, and the gradient means the direction of maximum increase of the loss. Now imagine that you want to reach to the exact bottom of the hill. So there are two options. You take a small steps, you will reach the bottom safely, but it will take a long time. Another option is that you take a large steps, that is you jump over the bottom. You land on the other side and have to jump back again. So you never stop exactly at the lowest point. So small steps is safe but slow. Large step keeps jumping over the bottom. Imagine that you are driving a car to a specific destination. Consider scenario 1 where the small learning rate, that is you drive a car slowly and carefully. It is safe and accurate, but it takes much more time to reach the destinations. Consider another scenario, for example large learning rate, that is you drive a car very fast to reach quickly, but you may overshoot the destination completely and you need to turn back repeatedly to fix the error. So small learning rate means slow and accurate, and the large learning rate is a fast and it overshoot the destination. Now consider the example 1 using a small learning rate. Suppose the current values given are current weight is 10 and gradient is 4, and here we are using a learning rate that is eta very small, that is 0.1. So use the update formula. Update formula is W new is equal to W old minus eta times gradient. So W old is 10 minus eta times gradient, that is 0.1 multiplied by 4. 0.1 multiplied by 4 is 0.4. Therefore 10 minus 0.4 is 9.6. So our W new is 9.6. Observe that here the weight change only by 0.4. This is very small update. Our old weight was 10, it was changed to 9.6, that is change is only 0.4. Now consider another example using a large learning rate. We keep all the values exactly as the same used in the previous example except the eta. So we use eta, that is learning rate 2 in this example, and keeping the current weight value as a 10 as it is and gradient as 4 as it is, same as the previous example. Now use the value in our update formula, that is W new is equal to W old minus eta times gradient. So W new is 10 minus 2 times 4. 2 times 4 means 8. Therefore 10 minus 8 is equal to 2. So our W new is 2. Observe here that the weight changes by 8. That is, previously the weight was 10 and now the new weight is 2. So the weight changed by 8. This is much larger step. During the convergence, the algorithm get closer and closer to the minimum. Suppose the minimum is 5. During the convergence, it get closer to 5.01, that is very much close to 1. The update become very small over the time. Initially it was 10, then it was 7, then it was 5.8, 5.2, and finally the algorithm settled down to the minimum. Now consider the another concept, overshooting and the on vacillation. The update step is too large, from 2 to 8, 8 to 3, 3 to 7, 7 to 4, 4 to 6. That means the algorithm move past the minimum and it repeatedly crosses the minimum and keep jumping. This is called as a oscillation. So effect of different learning rate. If the learning rate is very small, then training speed is also very small, but the stability is high, and long training rate is the only risk. If the learning rate is minimum, then training speed is also good and stability is also good, and risk is only the best choice. Usually it is a best choice. If the learning rate is very large, then training speed is very fast initially, but the stability is poor and large learning rate may overshoot or accelerate, or divergence may occur. Divergence means the algorithm moves farther away from the minimum. So if the learning rate increases, the size of the update also increases, and the probability that it will overshoot or oscillate or divergence is high. Choosing a suitable learning rate is extremely important, and it directly affects how reliably the model learns. So in order to avoid the oscillation at the minimum, we must use a small learning rate. Let us summarize it. There is no single best learning rate for every problem. The best values for the learning rate depends on the data set and the model. That is, if the learning rate is small, then it is a slow and steady. If the learning rate is very large, then it is very fast and risky. 0.001 is very small learning rate and it is used in deep learning. 0.01 is a very common starting point. 0.1 is often used for simple models. 1.0 is too large but sometimes works after tuning. The learning rate decides how much weight changes in one iteration. Too small, that is too small, slow convergence. If the learning rate is too large, then it may overshoot or divergence or oscillate. Thank you.